All right, y'all, we are going to jump straight into our next unit, which is just differentiation continued. So we are going to continue taking derivatives and learning some derivative rules. And today we're going to start with the chain rule. So write down 3.1 notes, the chain rule. And I'm going to highlight the things that you really need to write down. You do not need to write down the first thing, so this first little bit. The chain rule is used to differentiate composite functions. Composite functions, such as y equals square root of x cubed plus 2 or y equals sine of x squared. Remember that you create a composite function by plugging one function into another function. All right, and let's just like review that very quickly. We will always have a function inside another function. So let's look at this one over here. The function inside is x cubed plus 2, and it has been plugged inside to our square root function. All right, and then y equals sine of x squared, the function inside is x squared, and it has been plugged into, x squared has been plugged into sine of x. Okay, so we'll always have an inside and outside function for composite functions. Now I want you to write down the chain rule, but we're going to write it down in our own words. So let me read it first. The chain rule. If f and g are differentiable, then the composite function, and you need to make sure you know how to say this, so we say f of g of x. That's how we say this, and it's actually the same thing as this, so you can write it either way, f of g of x or f of g of x. The composite function f of g of x is differentiable, and it equals, and we're going to say, and equals f prime of g of x times g prime of x. Okay, so let's go ahead and write this down. So I want you to write this down now. Don't worry about getting the whole chain rule. You need to know this. F of g of x prime, so like the derivative of this, equals f prime of g of x times g prime of x. And we're going to write like a little rule to help us remember. We're going to write this rule. It's the derivative of the outside. Leave the inside the same. Leave the inside the same. Times the derivative of the inside. Okay, so what the heck did I just say? Here we go. Our inside function, I'm going to highlight in green. So our inside function to start was g of x. And then our outside function was f, right? The derivative is the derivative of the outside, f prime. Leave the inside the same. Here, I'm going to do the derivative parts in yellow, so sorry about that. Derivative of the outside, actually I'll do it in pink. Derivative of the outside, f prime. Leave the inside the same, so we just have the inside function, g of x. Times, so leave the inside the same. And then we have times the derivative of the inside, times the derivative of the inside, which is g prime of x. And we multiplied. Sweet. So that's how you take the derivative of composite functions. But we will probably be using this next method, the one that Leibniz, came up with. So here we go. This will allow us to use U substitution. So all you really need to write down here is, let's call U, or let's call the inside function U. So write that down. We're going to call the inside function the letter U. And then the outside is going to be V. And then we're going to say that the derivative the derivative of, I'm going to say this time d dx, because that means the same thing, right? The derivative of f of g of x equals u prime times v prime. You're just going to take the derivative of the outside, and multiply by the derivative of the inside. And this is kind of like a bad way of writing it, so I don't know, maybe just write this down. And then I'll show you with examples. Okay, so multiply the derivative of the inside by the derivative of the outside is basically the gist of the blue version here, and I'm going to show you with examples. All right, so the first example we're going to use the first version. Like, it's the same thing. We're doing the same thing. But why do we even need this? Well, let me show you. Without the chain rule, if we wanted to find the derivative of this function, we would have to expand. So we'd have to do, okay, f of x equals 5x plus 3, and then 5x plus 3 because it's squared, right? And then we'd have to like actually expand that. F of x equals, and we'd get 25x squared plus 30x plus 9 after doing a bunch of multiplication. And then the derivative, f prime of x, would equal 50x plus 30. Now, that's a lot more work than the chain rule. How do I know that this is a chain rule? Well, do we have an inside and outside function? Remember over here we were doing inside and outside function. What would our inside function be here? What would our inside function be in this equation? What's the function inside? All right, our inside function is 5x plus 3. And it's been plugged into the outside function, which is like x squared. All right, so with chain rule, watch this, f prime of x equals, we're going to do the derivative of the outside, leave the inside the same. So if we're taking the derivative of the outside, we'd bring this 2 out in front, 2 comes out in front. We would subtract 1 from the exponent using the power rule, leave the inside the same, plus 3, minus 1, that gives us just 1 as our exponent, times the derivative of the inside. So it's a derivative outside, leave the inside the same, times the derivative of the inside times 5. And you actually get to the same thing. This is actually the same thing. 50x plus 30. So this is way faster, and we're actually allowed to leave our answer most times in this form. We don't have to simplify any further. Okay, so now let's get some practice using the chain rule. And you need to write down these general rules really quick, the general power rule and general exponential rule. And they're right here. If g is differentiable, then this first one, the derivative of g to the n equals n g to the x n minus 1 times g prime of x for any number. And then if we have e to the g of x, so this is like a function inside the e function, right? Then we get this derivative. So go ahead and write those down. They might not make sense right now, but we're going to make sense of them when we do all these practice problems. Okay, on these practice problems, actually I'm going to give you some time to write these down. All right, on these practice problems, I'm going to use the u and the v method. So we said call the inside function u. All right, so first thing we need to do actually is rewrite this. And I'll do that in, let's see, purple. So I'm going to rewrite my functions to where they look like a power rule, just like we used to do. So I want to be able to use the power rule. The problem is I have this square root thing. I don't want to see a square root, so I'm going to rewrite it with an exponent. So we actually have x squared minus 1 to the 3 halves. Okay, I have not taken a derivative yet. I'm just rewriting this. Now I'm ready to use the power rule. Now, we have an inside function, x squared minus 1. We're going to say, let u equal x squared minus 1, and then v is going to be our outside function. And always write v in terms of u. So the first thing I want to do is highlight my outside function. Didn't we say x squared minus 1 is u? Yeah? So we could say v is u to the 3 halves, right? Because x squared minus 1 is u. So we're going to say let v equal u to the 3 halves. Okay, Now, we are going to take derivatives of each of these. So we're going to say, take the derivative du dx, the derivative with respect to x. These variables have to match. The variable in your denominator that you're taking the derivative with respect to needs to match the variable in your equation. So that's why I wrote du dx, and also the u, the thing on top, is your other variable. So derivative of u with respect to x equals, now we just take a normal derivative using the power rule, 2x. The 1 goes away, right? Derivative of constant is 0. Now we're going to take the derivative of this next, the bottom piece, v. We're going to take the derivative of v with respect to what variable? With respect to u, because v is this variable and u is the variable that v is dependent on. So now let's take that derivative really quick. We get, use the power rule, 3/2 u to the 3/2 minus 1. So that's 2/2, right? Equals 3/2 u to the 1/2. Okay, we're almost done taking this derivative. f prime of x. We were actually just trying to take the derivative of this the entire time. F prime of x equals, you're just going to multiply these. That's it. So you're going to take, let's see, you're going to take, oh man, I've used like all my colors. This and multiply this. That's your derivative. Now, the first thing we need to do, actually, before we multiply those, is plug back in for u. We do not want u in our answer. See this u? So what was u again? Let's go back. What did we call u? We called u this thing, x squared minus 1. So let's plug that back in. So we have equals, oops, sorry y'all, equals 3/2. Plugging back in for u, I'll write it in a different color for y'all, x squared minus 1 to the 1/2, right? Okay, now we're ready to actually write f prime of x. F prime of x equals the first derivative, 2x, the first derivative, 2x, that's here, times the second derivative, this one. So let me go ahead and write that, times 3/2 x squared minus 1 to the 1/2. And now we're going to simplify. Equals 3/2, that's 2 times 3. 2 times 3, it's 6 divided by 2. That's 3x times the square root, because 1/2 exponent is square root, and then we have x squared minus 1. Okay, that is your derivative, f prime of x. So go ahead and box that, and that's using like the uv version. So we'll always call the inside function u, the outside function v. We'll work our way out. We'll actually end up getting more than just 2 letters eventually. Okay, I know that was a lot. Let's try another one. We're going to try a lot of practice problems. Here we go. All right, y equals, we're here now, y equals e to the 3x squared. First thing we need to do is write what is u and what is v. What is u and what is v? So u equals my inside function. This one's a little trickier. What's my inside function? Anytime you have e to the something, your inside function is going to be your exponent. It's going to be up in your exponent. So u equals, sorry y'all, u equals 3x squared. And that means v is going to be our outside function, e to the, and then we called this function u, right? So v equals e to the u. Does that make sense? Because u is 3x squared. I'm going to highlight that just so y'all like make that connection. U was 3x squared, so now we're going to call it e to the u. Sweet. Now what we need to do is take derivatives of these. So du dx equals 6x by the power rule. And then dv, the derivative of v, the v function, with respect to u as my variable in that function, equals derivative of e to the u is just e to the u. Derivative of e to the x is e to the x. All right, the last thing we need to do is plug back into this u. Well, what was that u the same as? Remember, it was 3x squared. So we're going to say that derivative is e to the 3x squared. And now finally we bring these together. We multiply them to get y prime. Y prime equals 6x times e to the 3x squared. That is your derivative. Okay, let's do another one. Let's do another one. Here we go. We have cosine. Okay, this one we need to rewrite. We have cosine cubed. This is how you read this. Cosine cubed of e to the 5 theta. Now, really quick, let's rewrite this. Before we take any derivatives, let's rewrite this. You need to know that this is the same as cosine of e to the 5 theta. Theta is our variable. That's like x. This is like an x. Just be aware of that. But this is the same as cosine. Sorry, y'all. Oh my goodness. Cosine e to the 5 theta cubed. All right, that's the first step of solving this type of problem. This little 3, it needs to go on the very outside. So do you see how I rearranged this? I have not taken any derivatives yet. I haven't done any fancy calculus. All I did was rewrite what we started with. Y is cosine of e to the 5 theta cubed. Okay, now let's say what our inside function is. Let's say what our inside function is, and I've been doing that in green. The very inside function is going to be the thing on the very most inside of your parentheses. So what's on the very most inside of our parentheses? It's actually going to be 5 theta. All right, do we see how, remember, when you have e to the function, the exponent is your most inside. Then we have an outside function on that one, e. But wait, we're not done. We have to work our way out. Keep working your way out. That's inside cosine, so that's its own function. And keep working your way out. Finally, that's inside of this cubic function. So y'all, this is a 4-part function. And technically we could break it into 3, but we'll do that eventually. Okay, but let's try 4 parts. So we're gonna have variables for each part. U equals the most inside, that's 5 theta. Okay, V equals the second most inside, that's e to the u, right? Because u was 5 theta. All right, let's go with W equals, you could call it anything you want. W equals, you can call it any letter you want, cosine of V. Do you see how you always use the previous letter to define your functions? All right, and we need one more. Let's call it Z. Z equals, we're going to say W cubed, because we have to use this previous letter to define the next function. All right, y'all, this is crazy. Let's go ahead and take derivatives of all these, and then in the end, we'll just multiply them together to get our y prime, to get our derivative. All right, I'm not going to write all this stuff every time. So you're going to know that the pink represents derivative of each piece. So now I'm doing a derivative. What is the derivative of 5 theta? Theta is like x, remember. So the derivative of 5x is just 5. All right, derivative of e to the u is e to the u. But remember, u was 5 theta, right? So this is e to the 5 theta. All right, derivative of cosine v is negative sine v. But this is where it gets really weird. Remember, v was e to the u, so we have negative sine of e to the u. But remember, u was 5 theta, so this equals negative sine of e to the 5 theta. Do you see how we plugged in? I'll highlight it in a second. We plugged in for u we don't want u's or v's. We want like the variable we started with. We started with theta. So we need to get back to theta. Okay, let's take the last derivative. Derivative of z, or derivative of z, it would be 3w squared. But remember, w was cosine of v. So we're going to say that's 3 cosine squared of v. Because you could write cosine squared by putting the square in the middle. But remember, v was e to the u. So that's the same as 3 cosine squared of e to the u. But remember, u was 5 theta. So that's the same as 3 cosine squared of e to the 5 theta. Oh my goodness. These 4-part ones get kind of long. All right, so we need to multiply all of our final derivatives. So let me go ahead and highlight those. Here we go. We're going to multiply all of our derivatives, the final versions that are in terms of theta. So we have 5 e to the 5 theta, negative sine e to the 5 theta, 3 cosine squared e to the 5 theta. All right, we need to multiply all those together. So here we go. I'm going to write, I'll do it up here. Y prime equals 5 times e to the 5 theta times, make sure you put times or use parentheses. I would suggest using parentheses when multiplying these. So negative sine e to the 5 theta. Because if you didn't put a parentheses here, it would look like subtraction, which would be wrong. All right, and then finally, parentheses 3 cosine squared e to the 5 theta, parentheses. Boom. That's our derivative. Cool, huh? So cool. All right, just as a heads up, I told you I'd highlight it in a second. I just wanted to like let y'all know what I was doing here. U was 5 theta, so that's why I put 5 theta here, right? V is e to the u, so that's why I put e to the u here, but then remember u was 5 theta, so that's why I put 5 theta here. See how I'm like plugging back in what I called my original variables. W was cosine v, so that's why I put cosine v here, but v was e to the u, so that's why I put e to the u here, and then u is 5 theta, so that's why I put 5 theta here. All right, I know that like looks kind of crazy. Let's try a couple more examples. We have, just 2 more. Oh, 3 more. All right, we're going to go fast now because you've seen, I think, enough. Okay, here we go. I'm going to very quickly define inside function. Then we have second most inside function, the square, and then we have a third most inside function right here, natural log. So we're going to have 3 pieces. U equals the very most inside, x squared plus x plus 1. V equals u squared. And then let's go with w equals natural log of v. All right, let's take derivatives of each of these. So derivative of u is 2x plus 1. Derivative of v is 2u, which equals 2, and then u was x squared plus x plus 1. Derivative of w is 1 over v, because derivative natural log of v is 1 over v, equals 1 over v was u squared, which equals 1 over u was this long thing, x squared plus x plus 1 squared. All right, to end with my final derivative, f prime of x, we multiply all those together. What I'm going to do is put everything on top of this fraction. So like we're going to multiply 1, and then these pieces are going to go to the numerator. All right, so we have f prime equals 2x plus 1, because we're just multiplying, and the whole numbers are going to multiply to the top, times 2 times x squared plus x plus 1 over x squared plus x plus 1 squared. All right, I know that we can simplify that, but we do not need to, at least not for now. At least not for now, because we're going to pretend that we're doing like multiple choice or a short answer, in which case you would be allowed to leave your answer like this. You do not have to simplify your short answers. Okay, and let's move on. This one's kind of tricky. First, we're going to rewrite it. So this equals cosine of 4x squared minus sine of 4x squared. All right, and then u equals your innermost function, 4x. V equals, well, we have two v's. So we have cosine of u, and then we have another one for this guy. So we're going to actually do two derivatives. Oops, v is sine of u for this guy. So v equals sine of u. And then w equals v squared. Same for this one. All right, and then I'm just going to go ahead and do these derivatives very quickly. So we have 4 negative sine of u is 4x. And then we have 2 cosine of 4x. And I'm plugging back in as I go, which I don't know if I would encourage y'all to do that. Not quite yet. Okay, derivative of sine, that would be cosine of 4x. And then v squared would be 2 sine of 4x. Sweet. So our derivative, g prime of x, equals, for the first piece, we have multiply all these three together for the first piece. So we have negative 8 sine 4x cosine 4x. I multiplied the 4 and the 2 and put the negative in front. And then we have minus, because of this minus sign, minus 8 cosine 4x sine 4x. So same thing. Sweet. All right, we have one more type of problem to look at, and then we're done with notes for the day. So let's go ahead and look at this next problem using the chain rule with the table. Let f be continuous and differentiable functions on the interval 0 is less than x less than or equal to 1. So x is in between 0 and 1 or equal to. Let g of x equal f of 4x. So we have a composite function here. G of x is equal to f of 4x. 4x is my inside function, f is my outside function. The table below gives values of f prime. Sweet, so these are derivative values of f. And find the value of g prime of 0.2. So we're trying to find this, g prime of 0.2. Cool. The first thing we're going to always do is find g prime of x. That's what we're going to do first. But first, actually, before we do that, let's go ahead and write this down, what they gave us. G of x equals f of 4x. And now we're trying to find what is g prime of x equal. Well, we have an inside function, so we need to use chain rule. U equals 4x. V equals f of u. What is the derivative of 4x? 4. Derivative of f of u? F prime of u, right? It's just the derivative of f, but leave u inside. Now, what is u? U is 4x, right? So equals f prime of 4x. Cool. G prime is going to be these two things multiplied together. So g prime is 4 times f prime of 4x. Awesome. Now, we can now take our x value and plug that in. So 0.2. G prime of 0.2 equals 4 times f prime of 4 times 0.2. Well, what is 4 times 0.2? That would be 0.8. So we have equals 4 times f prime of 0.8 0.8. All right, and now let's go ahead and plug in for f prime of 0.8. F prime of 0.8 is 1.125, so equals 4 times 1.125. Done. You can leave your answer, your final answer, like this, because we do not have to simplify. All right, good work, y'all. I know that was kind of long. Let's go ahead and break into practice.